trying to expand it to other situations. You have to be really careful when you're doing that to explain it to your kiddos, so that they don't think that any set of data can have a line drawn through it. Because in Algebra 1, we sometimes do that. We start with concrete data, and then we draw that line. And sometimes it doesn't have to do with time. You know, if there's time involved, then that line's gonna be there, because time is continuous. So don't look at me like that, Melissa. Teachers do that all the time.
No, I'm thinking I still don't understand really, then, I don't understand why you put a line through it, because to me, we don't know what X or Y is.
Exactly. We don't know, so it is possible, if we continue that table, that we could have some fractional numbers in there. We're not dealing with concrete materials.
So you don't know that either.
But we don't know.
Right.
We don't know what you did, you don't know what you did.
That's
So that's why
right,
you
we don't know.
You could have had little squares.
That's right, we don't know, so we can draw the line because we don't know.
We cannot draw the line.
Or we could not draw the line and have that discussion. As long as you have a discussion and the students clear it up in their heads, it's fine whether you draw the line or not. Okay? All right, so does this one go through the origin? Yes or no? Brenda, hit me every time. Leslie,
Yes.
did this graph go through the origin?
Yes.
Yes, it did. Thank you. Patricia, is this a line? Is this a linear graph?
It is.
It is a linear graph. So Brendan and Brandon looks alike. I think that's Brenda. So Brenda, would you say that the data here is proportional?
Yes,
Tell me why.
so if, does it matter which one I use?
It's your explanation.
If I use the graph, it is a constant slope and it goes through the line goes through the origin, and the distance between each point is, consistent.
Okay, so the rate of change between the points is consistent for the y,
Yes,
also consistent for the x.
correct.
And it goes through the origins, so it is a proportional relationship. Okay, thank you. So, all of that was to finish up this, to show you the abstract and the pictorial part, all right? So now we're going to, and that came right out of this book, which you will be getting. In the back of the book is a little CD that, according to the two ladies sitting in the back, I could not get to work. It's password protected. The password probably came when the books were ordered and that package was opened, and that paperwork is who knows where. So if the CD doesn't work for you, I'm sorry. But all of the Blackline Masters in here are actually on that CD. So if you have some magic IT person, you can get to it. That's good. Also, there are some articles, and I'm going to give you one of those in a minute. But right now, I want to go on with my rest of the activities for today. Yes, ma'am.
So, if we did all this,
Yes, ma'am.
in concrete, so this could be a summative assessment?
Yes, ma'am.
Or the ever so necessary grade that we have to put into?
It could be. And then you'd have to make that decision to draw a line or not to draw a line.
But in fifth grade, I don't know if we would discuss drawing a line or not drawing a line, but we have to get to them to the abstract.
You
Right.
have to talk about discrete and continuous. They have to know the difference between discrete and
No,
Fifth grade?
No, they don't. That vocabulary was used in the.
they have to know the function, y equals a plus
Okay,
x
we
and
can
y.
look that up later, okay, because we have to finish this. So, what I listened for when I walked around, and all these questions are in this book, is how did you set up your coordinate grid? I watched them, I even stopped and asked some of you some questions about your grid, right? Some of you I said, which is the X or which is the Y, or something similar to that, because they were not labeled. Some of you did not have the numbers on there. So I'm trying to make sure that they get the grid labeled correctly so that everybody knows what's going on. Are y'all, Jen, did you hear what I just said?
Yes,
Tell me again.
you said that, okay, no.
Thank you. Rochelle, what did I just say? So I'm gonna have to read. Could put it up. Okay, sorry. So what labels did you use? You'd have to hear them discussing that. How did you determine the missing values? That's in the table, okay? Did they use the graph? Did they back the table up? Did they run the table forward? Did they use the rule? You want that discussion to come out. Of course, y'all being teachers, that discussion came out without me having to ask, but you'll have to ask your students. And again, all these questions are I copied them right out of this book. Well, I changed them a bit because many of them were yes, no. So I changed some of them. Describe the rate of change in the table, which we did in the table and the graph. Okay. How does this relate to the rate of change in the graph, which we just discussed ad nauseum? How do you locate points in the graph that are not in the table? We did that with the 2.5 and the 10. Okay. Was there a recursive rule? Let me see.
What's recursive?
Was there a recursive rule? Alyssa, I'm gonna give you all about 10 seconds to discuss that with your partners, so that Leslie can get caught up.
Is, it's contingent on the step. There's a rule for that. Reading, well, I don't know what recursive part is in. So what's your rule if I go from, on what, 8 to 12, 12 to 16, 16 to 20, 20 to 24, is there a That's right, that's your rotation. Okay, so 2 to 3, plus 1, right. So that's your recursive, only you have your each side, what the X is doing, what the Y is doing. Right, from step 1 to step 2. Now, what are the disadvantages of just thinking about recursive? You can do that.
Okay, 3, 2, 1. Alyssa, I have drawn your name. What, is there a recursive rule first? And if there is, what is it?
Yes, ma'am, there is a recursive pattern, and the recursive pattern is +4.
On the y-axis.
On the y, yes.
What about the x values?
Yes, ma'am, there is also a recursive pattern, and that is adding 1.
Adding 1. So that is actually this. Your kids don't need to know that, but that is actually this. All right, so an explicit rule. Gloria.
All right, so, from what I'm gathering, the recursive rule is not dependent on the x, it's just on the y. Just looking at either the x or the y, that's the recursive. So,
It's depending on the table. It's what happens in the table as you go down, okay?
and so the explicit rule is the relationship between the x and the y.
Nicely said. It's a relationship between the x and the y. Instead of going down to find a pattern, they're going across to find a pattern, and in this particular one, the pattern is to multiply the x by 2 to get the 1. So in yours, what is the relationship? What is the explicit rule?
The explicit rule, is, multiplying 4 to the x value.
Okay, 4 times x, and that's going to give you the
Y value.
the y value. Nicely done. Yes, sir.
It was stated that the recursive rule was +1 and +4 respectively to x and y.
Yeah.
But I thought you had to do one rule, so it's just y divided by x, right? For my recursive rule. And I can't have two different, well, I was under the assumption, can I have 2 different rules that have to be
Oh, I see.
one?
That's a great question. So his question is, can you have 2 different recursive rules? Can you have one recursive rule for the y values and a different recursive rule for the x values? That's the question. And so we're going to have Tim talk about that. Being a science person.
So, the question is, can we have a recursive rule which is different than our explicit rule?
No, the question is, let's look at this one. What's the recursive rule for the y values here?
+2,
+2. What's the recursive rule for the x values here?
+1.
+1. Do these 2 recursive rules have to be the same? Because they're not here.
No.
They don't have to be the same?
I'm sorry, I don't understand. What does it have to be the same?
Thank you, because my language was sloppy. We have a +2 recursive rule here.
Yes?
We have a +1 recursive rule here.
Correct.
So Brandon is asking, does the recursive rule for the y values have to be the same as the recursive rule for the x values? But then I finished that question. Does the recursive rule for the y value has to be the same as the recursive rule for the x values?
Well, we're looking for the relationship between the two values, whether it,
Not right now, that's explicit, I'm just talking recursive. Does the recursive rule for the y values have to be the same as the recursive rule for the x values?
no,
No, Brandon, that's not your question, you said.
Yes, ma'am.
What's your question?
I just thought we had to have one apiece. So my explicit is one rule, that's for y equals 4x. And you're telling me I have 2 recursive rules. So to me, my recursive rule for that would just be y divided by x. That's how I figure out the pattern.
Once you put an x and a y in the same sentence, that's an explicit rule. That's not a recursive rule. Okay, so if you have an x and a y, that's explicit, because you're relating the x and y values,
So I'm going to have 2 recursive rules.
sometimes. Not all the time. There are
I think
graphs.
that's
This
where
one
we were
doesn't have
discounting
two
the
different
x
ones.
is changing by 1.
Yeah.
So our recursive rule wasn't +1 because x is changed by 1, it's the +2.
Oh, okay, I think I see where you're going.
That's where
We
we are.
focused on the recursive rule of the y.
Yes.
We did not focus on the recursive rules of the x's.
We assumed you didn't,
Yeah,
that wasn't a thing.
but you can. But we usually focus just on the recursive rule of the y. Usually, especially if this is 1, 2, 3, 4, 5, consecutive. Did that clarify? Sort of? Okay, Ashley?
So how would you write a recursive rule? I mean, you could say +1, well, +1 what?
It's just a value. So if we have this table, let's see, can somebody bring their table up here? Is the table still here? We'll just use this one. So I have to go to computer. Okay. You see how this little 5-minute, I told Sandra this will take us 5-10 minutes maybe. It's been an hour.
The only reason I say that, because in 5th grade, one of the things is they have to find the rule.
Yep.
Does it specify what type of rule?
Yeah.
Y equals x plus a, or y equals x times a. But that's, y equals x plus a is not the same as what you would find in a recursive rule. I wanna make sure it's done correctly, because they're not the same. Meaning, y equals x plus a would be an explicit rule.
Because you have both values in there, both variables.
Right, but if they see this, they may say, oh, well, y equals, it may +1. I could see that. I would be that child going, well, the recursive rule is +1. It's like, well, no, it's,
The recursive rule in the x values is +1 in this table.
right, right.
The recursive rule for the y values is +4. And we eventually, we will talk about both because that gives you your slope. Change in y over change in x. So that's 4 over 1. So
Okay.
both recursive rules will give you your slope
Okay.
if they're consecutive.
Which is where he was saying about if you fix the y over the x, so he was already going to that step.
He's always way ahead of me. So, yeah. There was a hand? Any other questions on this? Okay, so now I get to, since she walked out of the room, see if I can get back to the computer that I need. Alright. So this one little brief activity that I truly thought would only take us 5-10 minutes has taken us a long time. Number one, because I kept asking questions, and number two, y'all kept clarifying your thoughts and also my questions. Okay, great conversation, I appreciate it. So, we've already talked about this a bit, recursive and explicit rules are related. Okay? because the recursive rule for y over the recursive rule for x will give you your slope, which is in the explicit rule. Remember, I did not write it down. The 4x equals y. So, just a little bit about learning and cognition. Learning and cognition are not the same thing. They are not the same thing. Cognition is, let's see, Patricia, what is cognition?
I don't.
You want to phone a friend? And what is cognition?
Thinking.
It's thinking. That's all it is. So, thinking about things can happen in a lot of ways before you learn a concept. You could have discussion, as we just did. You could use trial and error. You could do a whole lot of things to think about something before you actually learn it. So your cognitive processes are going on all the time, and then you finally learn the concept, right? So cognition and learning are not the same thing. You have to do a lot of cognition stuff to learn something, okay? So, of course, behavior also influences what you learn. The environment, behavior, and your cognitive processes influence what you learn, all right? So how comfortable would you be if I asked you to describe and explain Bloom's taxonomy? Amanda S.?
That is this,
Just how comfortable would you be?
middle,
Middle comfortable? Okay, so you've heard of it. You may not.
I could spell it and I know a little bit of it, but I couldn't go like without notes guiding me through it. I wouldn't be able to do that.
Okay, so you can spell it, and she can kind of remember some of it, all right? What about Costa's taxonomy? Aubrey? Never heard of it? All right. What about Webb's levels of depth of knowledge? Amanda B.
I would have a fair understanding.
You do? Okay, good. So, what about Hess's cognitive rigor matrix, Melissa?
I would believe a fair understanding of that wonderful matrix.
Okay, so Melissa, where did you get that fair understanding of that wonderful matrix?
This awesome lady called Dr. Browning, who showed it to us last summer.
She was here last summer, we talked about this
And
last
went
summer.
over it, we had a lot of fun with it.
It was fun. So Amanda B., where did you get your somewhat knowledge of Webb's level of depth of knowledge?
Professional development courses.
Okay,
I have a book.
you have a book, good. Most people are not familiar with the bottom tree here, but they are all related. So let's look at these really quickly. Let's go skip that for right now. Let's skip that for right now. We'll go back to those next time we meet. Here's Bloom's taxonomy. Okay, 1956, Benjamin Bloom and his group, he was not alone, came up with this taxonomy. And on the bottom is knowledge, understanding, application, analysis, synthesis, and evaluation. You've all learned about that in your coursework in college, I'm sure. It may not be hanging around right at the front of your brain, but you've heard of it, you know it. If I reminded you, which I just did, you know it. So they identified those, and knowledge is the lowest level of questions. If I said, what color is this cup? That would be a knowledge level question, because if you know your colors, you know, you just know it. And you know your colors by what, the age of 3? 4, maybe? So Benjamin went around, and he listened to thousands, he and his group, of teachers, and he recorded their questions. He recorded their questions, and that's how he came up with this hierarchy. Okay, it didn't just come out of his head, it came out of action research. This hierarchy, he said, oh, these questions appear to be just asking for knowledge. These questions appear to be having the kids synthesize something. So they came up with their hierarchy. And they also discovered that 95% of test questions, and also questions that teachers asked in the classroom, were as the lowest possible level. So if you're asking your kids the lowest possible type of questions, how well will they do on STAR? Let's see. Rochelle, how well? Just give me two. Really well, not so well.
Well, I don't think the STAR is only gonna be recalling of the facts, so, not, well.
Not as well as you would hope, maybe we should put that. Not as well as you would hope, I would agree. So back when this whole state testing thing began, you know, when I graduated from college, I took no exit exam. I passed my courses, they gave me my degree, and they said, go teach. Maybe an explanation of why I taught so poorly those first 2 or 3 or 4 years. There was no state curriculum, no TEKS, nothing. They gave me a book. Hang on. They gave me a book and they said, go teach. Okay. So when I had my first book adoption change, they gave me 4 books and they said, pick which one's the best. Did I know which one was the best? How was I going to base that? I had no clue. So I just picked one that I thought the kids could read. I went up my reading level. And it turned out to be not a bad book, but it wasn't a really good book either. I had to supplement a lot. So, I haven't forgotten back to Dr. West, but we're still going on. I had taught 15 years before we had a state curriculum, it's not a curriculum, a state set of standards. 15 years. It was called the EEs, Essential Elements. There were like 592 for 8th grade, which is what I was teaching at the time. And we wanted to march through those essential elements, just, you know, okay, gotta do this one, gotta do that one, we never thought, or I didn't, about bundling them, trying to make them fit, you know, I would never teach measurement with adding and subtracting of something, that just wouldn't work, because that one was in 1 and the other one was in 10, okay? So it wasn't a very good system. So they redid that, and they came up with the TEKS, which make a whole lot more sense. So the first state test that my kids had to take was TABS, Texas Assessment of Basic Skills, and it was indeed basic. Very few words on the test. All of the addition problems were vertical, so that they could remember to carry and to borrow, that kind of backwards language. Well, after TABS, some of you are shaking your head, what came next, Ashley?
The test. One task? Toss?
Leslie?
Teams.
Teams.
Oh, that's right.
Texas. Evaluation. Academic minimal skills. After teams.
Or task.
TAS was a college one. It's to get into college.
Oh, that's right.
So
Yeah,
toss.
toss. I took the toss test.
Texas.
Assessment of academic skills.
Academic skills. Took out the minimal, right? Each time the test got harder, guess what all the teachers did, me included? Oh my gosh, my kids are gonna pass. This is too, I don't agree with this. TABS was okay, it was basic, but this is too hard. Look at all that reading in there. Oh my gosh, we're not supposed to read in math. After TAS, tax, Texas, knowledge and skills. I love that test. They actually tied it back to the TEKS. Texas Essential Knowledge and Skills. Texas Assessment of Knowledge and Skills. Makes perfect sense to me in my little linear brain. And then STAR, I don't know where they got the name. I know what it stands for. I can never remember. Each test became a little more difficult in cognition. Yes, ma'am.
Didn't at some point in there, Mark White had teachers take a standardized test?
Yes, they did. I've been teaching for a very long time, and Mark White did decide that teachers didn't know what we were doing, and we should take a standardized test, and it was called the TCAT, Texas something, TCAT. And guess what it tested? Math and literacy. I'm an English minor. I'm a math major, English minor. Ask me how long I studied for that test. Zilch. My husband, social studies, coach. Ask me how long he studied for that test. Hours. I didn't even go to study groups. I stayed home. And he got mad at me because I didn't study, but I passed. He passed, and his friend he was studying with failed. Anyway, Sandra, you had a question? You forgot it.
Well, I had, two comments. There were teachers who failed this basic English and math test.
Absolutely, there were.
My mom worked in the school system, in central office, and she got to see them. And I was in the 8th grade, and she said, Ashley, you should have passed it. You would have passed it.
It was not a difficult test, especially for a math major, English minor, my thought.
It was not difficult for a science person either.
It's
No, the
basic
point I was
grammar.
gonna make earlier, that whenever Browning and I went into the classroom, we did not have a research base for best practices.
Nope.
It did not come until the 90s, I guess it was.
Yeah. Late 80s when the TEKS and all that
So
came out.
y'all, you have such a great advantage in that we know what works. So we can tell you it works if you go from concrete to pictorial to abstract. You know, we know that there are things that work.
We know questioning strategies work, we know
Yeah.
help strategies work, we
Yes.
know all of this.
Yes.
And literally, when I graduated, it was like, oh, glad you spent your money with us, have fun here, go teach. Okay, and I'm secondarily certified, so, I was in a FOM class.
I don't know what FOM is.
Fundamentals of Math, in a very
Okay.
small school, so I also had pre-cal, geometry, 7th and 8th grade. 5 preps, with not having a clue what I was doing, and I was pregnant, so it wasn't a good year. But, moving on. So, later, in 2001, some people got together, and I don't know who, and they revised Bloom's. These were all verbs: define, duplicate, label, analyze, appraise, calculate, categorize. And they changed those. It says make judgments based on criteria, carry out or use a procedure, concrete meaning, clarify, paraphrase, represent. So they clarified it a bit, made it a little bit more understandable. Because I'm telling you, having a collect verb down here and synthesize, teachers, sometimes they had things people collect things, and really that should have been up there in knowledge, because they were just collecting worms on the playground or something, okay? So that was confusing. So it was revised in 2001. And then Costa came along and he said, that's too complicated. He put it into 3 categories. The first 2, knowledge and comprehension, he said, well, that's just gathering knowledge. The next 2, application and analysis, he said, well, that's thinking about the information. Tax was there. And the last 2 are making judgments, evaluating and synthesizing. Okay, that's Costa. Which is really Bloom's, just kind of simplified. I don't see the value of that because that's common sense to me. And then Webb came along and he said, really, Bloom's was about the verbs, calculate, collect. And Webb was how deeply you understood the content. How complex was the content. There are 4 levels. Level 1, recall and reproduction. Level 2, applications. Level 3 is strategic thinking. Level 4 is extended thinking. Okay? So, it's what comes after the verb for Webb was just as important as the verb that was used. For instance, if I said, describe the physical features of a plant, not a manufacturing plant, but an agriculture plant, Suppose I said, describe the physical features of a rose.
Are you asking me to do that?
Yes, ma'am.
It has petals, and the petals are red.
Sometimes.
And it has a stem, and there are thorns on the stem, and it smells good. I think it does. It has many petals that are in kind of a bell shape, and they kind of layer on one another, getting smaller as they go in.
Okay, so she described it. So what level on Bloom's would you call that question? Describe the physical features of a plant. What level on Bloom's? Brenda? Knowledge, okay? I would agree, knowledge. What if I said describe, same verb. Describe how squares and trapezoids are alike and different. How would you answer that one, Kim?
That's a compare and contrast, that is analyze.
Analyzing? It's not knowledge, is it? Analyzing?
You have to take the knowledge and think about it.
Okay, alright. What if I said, describe the most significant effect of World War II on the nations of Europe? Where would that be on Bloom's, Tim?
Evaluate.
Evaluate,
Bloom, revised or original?
either.
It would be at
Basically,
the very, that would be evaluate on the future.
evaluate.
Synthesize
Now,
on the.
some people have switched the order of synthesize and evaluate, because they say you have to be able to evaluate before you can make your own synthesize. I don't really care if they switch them or not. So, same verb, different levels of questioning, of cognitive rigor, different levels, okay? So,
Excuse me, could I interrupt here?
of course,
Thus, the focus on the verbs in the teaks. Okay?
maybe shortchanging your students if you focus
Absolutely.
just on the verbs.
Yes.
Now, the verbs are important, don't get me wrong, but it's what the verbs also imply or what comes after the verbs that's just as important. And I'm looking at your faces, I do apologize to the people last summer who are just sitting through this all over again, okay? But I suspect that you didn't remember all of this, so it's a good reminder, all right? So, I don't know what time lunch is going to be here.
We haven't got the word, carry on.
Okay. So, when you're teaching in your classroom and you have formative assessments and even summative assessments, you don't want to assess at just the highest level because you need to assess at the lower levels, especially when you're beginning your lesson and you're accessing prior knowledge. So all of the levels are important, but what most teachers miss is they don't ever get to the higher levels in their questioning. They're higher levels. Look at all the questions we talked about when we did that activity and now today. Those questions were pretty high level. If I had not ended them all with a yes or no, they would have been very high level, okay? So, all levels are important. So, I'm trying to hurry through this because I want to get to one thing I know before we get to lunch. So the age or the grade does not determine the level of the depth of knowledge. You can't say that all first grade questions should be level 1 and all calculus questions should be level 3 or 4. You can't say that. You need a smattering of all levels at every grade, at every age.
In your lesson plans.
Yeah, that's why I'm doing this today, because your lesson plans. You're probably at the point where you're writing your questions, right? Close to it, you've already written some. Okay, so this is important. Anything that's routine, that can be memorized, is actually level 1. So if you can memorize how to do long division, that's level 1. That's level 1. It may be difficult at first, but it's not cognitively rigorous once you memorize the algorithm. Now, if you make the child do several different ways of long division and relate them, then that's a higher level than 1. But if you're just memorizing how to focus whatever you're focused in, a microscope, that's a level 1, okay? Teachers argue with me about that all the time because long division is really, really hard in 3rd, 4th, 5th grade. But it's still not cognitively rigorous. They just haven't memorized the algorithm yet, okay? So it's level 1. So any skill is going to be a level 1. Conceptual understanding is level 2. So where should a teacher always begin their lesson? Where do I always begin mine? Or Tim?
Level 1.
Do I?
Level 1 or 2.
Do I? Let's see.
Some of them have, at least for me, been at least 2, sometimes 3. I mean, you've got to, just from my experience, especially working with the concrete and the manipulatives, is so far outside of what I'm accustomed to. It's not the standard algorithm, it's not the automatic math facts, it's thinking deeply about, okay, what is this red, blue, and green tiles? How is that going to become the same thing as flip and multiply, or, you know, the Cuisinart rods?
Yeah.
in making the connection.
So 2 or 3.
I think so.
Melissa, your thoughts? You raise your hand up.
I was just, it also depends on your audience, because the elementary don't necessarily, like, some of them never heard or like done slopes in college. Whereas if you've taught 7th grade and things like that, so for us, that wasn't hard. So their level, they might have thought that the questions were a higher level because of the knowledge base.
That's a great point. So here we talked about changing y over changing x, we called it slope. We had the formula. So finding slope, the way I did it up here, was that level 1, 2, or 3? It definitely was not 4. There aren't very many 4s in public schools, and that's fine. So Pam, the way I found this up here, was I asking questions level 1, 2, or 3? Get your gut feeling. Some of them were 2.
Just plugging in numbers.
Some of them were 1, a lot of them were 1. So this was difficult for some of you because you either never learned it or had forgotten it, but that difficulty does not make it rigorous. It did not take a whole lot of cognition to do all of this. There was no problem solving here, was there? No problem solving. We were following a rule, plug and chug. It is abstract because it was all numbers and letters, but it was not rigorous. So it's not level 3 at all. Now, when we went back to the tables and we related the table to the graph to the function, what level do you think that would be? Among webs, not blooms, webs. 1, 2, or 3. I guarantee it's not a 4.
I would say more 3.
Or 3, 2.5, 3-ish. You know?
It's 3 because you required explanations for a reason.
I did. Explanations, justifications,
And multiple sources.
multiple sources. So we're getting to the 3 level there. So it's not really hard to get to 3 if you're judicious in how the questions that you ask, not yes or no. I've been a really bad example today. But good, really good high-level questions, and you make the students explain and justify. That's why I like chart paper. I like public display so that the student is accountable for explaining how they got what they got. Okay? Level 4 is more PBLs. Okay, you get to level 4 if you're doing some PBLs, all right? Which in most classrooms that doesn't happen regularly. So you should focus on levels 1, 2, and 3 when you're asking your questions, when you're writing your lesson plans. Effective teachers base their teaching on level 3 discourse. That means the conversation in the classroom should focus on level 3. Now you're gonna have some level 1 questions in there. You're gonna have some level 2 questions in there. But you gotta have level 3, and I usually start with a 2 or 3. If I stood up here and gave you vocabulary first, or gave you the formula first, starting with level 1, shuts down all that cognition. You know, they're just memorizing after that. You have to start with a really rich activity to begin this. I hope I'm not boring y'all. So, using manipulatives to demonstrate how sets can be joined, you know, that's going to be level 2, maybe level 3. So when you're writing your lesson plans, these are important questions. Why are you teaching it the way you are teaching? Why did I make you use the pattern blocks to do that? I could have given you the table and said, find the rule. That's where I wanted you to head, right? I wanted you to get the rule. Did I give you the table and say, find the rule? Of course not. Did you have your hand up, Amanda?
I would have never learned, if you would have done that, I would have never learned about the line.
What about the line?
About whether the points on the coordinate plane to be connected.
Okay, discrete or continuous data.
I would have never learned that.
No. And you would have learned about changing y over changing x, that recursive rule that we talked about. Or there are a lot of things you probably wouldn't have learned. You cannot start with the rule and then expect kids to then go to that because they're not going to do it. They're not going to make that complete. Why should they? They've memorized. So Heston came along, Karen Hess, and she developed a matrix. And this matrix has 24 cells. She kind of tied Webb's depth of knowledge to Bloom's taxonomy. So Bloom's is going down, and she used the old Bloom's, as you'll see. Bloom's is kind of going down. No, these are the new Bloom's. Yeah, these are the new Bloom's. So remember, understand, apply, analyze, evaluate, create. And across the top are Webb's depth of knowledge. Okay? So if you have a remember in Bloom's, that's a level 1 in Webb's. Can't be a 2, 3, or 4, so there's nothing in those cells. Right? If you have an understand in Bloom's, you might say that in such a way that it's a level 2. If you have them generalized, it could be a level 3, but you have to really know what you're doing and plan your questions really, really well. So I have this, and this is specific for math and science, that I want you to use when you're writing your questions for your lesson plans. So there's the Hess's chart. Right?
It's in lilac, which means it's research based.
Karen Hess, she has a website, she's got lots of great things on that website. A lot of what she has on there is her opinion, so be careful about that. But she does have some research on there. Karen Hess. So this is what I want you to do, and I hope we have time to do this. I have the story, Little Red Riding Hood, here. And I want you to read the story.
Actually, we need to go.
We need to go. We can read Little Red Riding Hood when we come back and maybe finish it real quick.
Yeah, I have 2 things. Go back 5 slides, and while you're doing that.
You counted?
Go back. Stop. Okay, right here. What did we say about what is a general type of lesson for skills or procedures versus conceptual? Direct instruction for this tends to work better, and inquiry tends to work better for this. Look at the difference in the 2 levels there. Okay, the second thing is that you know we're going to be coming into your classroom. Our job, it's a coaching job, okay? We don't do assessments or anything like that. We're also trying to train your principals. And so we're hoping the principals want us to go in there with you. So the idea is, we know you're gonna be using some best practices. We know that, we see that all the time. So the idea is for us to identify what the best practices that we're seeing in your classroom with your principal there, so they can see what it looks like in math and science. We're not gonna come in any other classes, okay? And then we have a chart that we have created, Dr. Kern and I created, with Browning and some other people, Laura, et cetera, about what would enhance or what would impede your STEM instruction, your math and science instruction. So we have the latest draft. We'd like for you to look at it during lunch and make some notes on it. You know, do you agree? Do you disagree? Do you have some other suggestions about things that may have occurred in your experience that you could add? And lunch is on the table.
All right.
Okay.
So we'll pick up here when we get back. It won't take 2 minutes.
Jennifer, so you may be looking for full size. Can I take this down?
Wow.
I know they have.
We're saving water bottles, don't forget.
Put it back there.
No, I think
Sixth grade
I'm
kids
gonna do.
don't need water bottles.
Yeah.
From 35, and you go
we just need the data for your office.
I'm gonna try, if, when you turn, you go outside the loop,
Figured it out.
and this is Evers Road,
Have they maybe
you go
Yeah.
down Evers, you go
And
through the, through the little word.
finally got it.
On the left to the north side, this is house is mine. I don't share my.
Is that what's in that box right there?
No, it's not, it's in, that, it's what was in that box, and that's in the bag.
Good.
From the
Well, I need,
it's not.
I need to go eat.
And that's going to be.
You're locking the room, right?
Yeah, lock in the room.
I'm the closest to the northeast school that I can be from where I live. If I make all the lights, it's 9 minutes. If I don't make the lights, it's between 12 and 15. So, I was just saying, from the time I get in my car till the time I walk here, it is exactly an hour.
Me too.
So I always make sure that I leave right at either a quarter till or 6:30.
Yeah.
Or 6:45. So, Dr. Browning said I may do the banana lab tomorrow.
That's what we're thinking.
Okay, I did not bring my laptop, just walked away, left it. So, I just may go on home and work on it and keep texting back and forth with her.
Okay, and then I need
I need to
a
go buy
printout.
bananas.
Huh?
I need to go buy bananas.
Yeah, but I need a printout when you finally finish your PowerPoint,
Okay,
so we can make notes of it.
okay, that I can do.
Okay.
So I may just go on and go now,
Okay,
if that's okay.
sure.
I won't bug you for lunch.